Good afternoon. I know it's after lunch, let's try that again. Good afternoon. My name's Kevin Poorman. I work with the Marketing Cloud. I am a customer success architect there. And today we're here to talk about Apex promises. Anybody ever heard of a promise? Was it in the context of politics? Not those kinds of politics, or not those kinds of promises, excuse me. A little bit of housekeeping. There's going to be some time where we're going to have Q&A here at the end, and there's a mic right there in the middle of this. This session is being recorded, and if you use the microphone, everyone will be able to hear your excellent question. Otherwise, I'm going to have to repeat it, and I may use a French accent. All right, I like to do interactive presentations, excuse me. It's Thursday. When we get to things, feel free to ask questions, even if it's not the QA section. I'll try to queue it up for the end as well. So with that said, we're going to talk about Apex promises, but before we can do that, I try to make all my slides visually interesting. Most of them have an Easter egg on it. However, the people in legal seem to have no sense of humor, and I have to leave this one completely unmodified. If you've never seen this before, congratulations. This is the forward-looking statement slide. It means that I may accidentally talk about something that is not yet released. It's a forward-looking statement. If it's not released yet, you shouldn't make purchasing decisions based off of it. Again, please make all purchasing decisions based on what is freely and publicly available. All right? Questions? Snide remarks? Thank you, legal. So here's what we're going to do today. We're going to talk about what a promise is. We're going to talk about why you should care about promises. We're going to talk about promises and asynchronous programming and chaining and how that makes everything better. We're going to talk about the Queueable Apex interface, which enables promises to be done on the Salesforce platform. And we're going to chain some of those Queueable Apex classes together. And finally, we'll have some Q&A and resources. 10-second dime tour of the entire talk. Now you've heard everything. Have a great day. So, what is a promise and why should you care? Promises are a data structure. And as a data structure, they have three states. They have a pending state, they have a fulfilled state, and they have a rejected state. Now, if you think about a promise in the context of those three states, it's pretty obvious what's going on here. During the pending state, or while the promise is in a pending state, something is happening. And that something is probably not forefront in the application's lifecycle. It's happening in the background, it's happening asynchronously. When that work is done, it either becomes fulfilled, which means, hey, I did all that work, it worked, here's the results. Or it got rejected. A promise, therefore, is kind of an asynchronous way of doing if then else, because it gives you a bit of a way of doing asynchronous work and then doing an if else on whether or not it was rejected or fulfilled. And one of the great parts about promises is when you get done with that asynchronous work, you can attach something else to occur. So here's how they kind of work in sort of an overview flow control thing. You're going to have a promise, and a promise can do some sort of asynchronous work. When that's completed, it's going to turn around and make some more asynchronous work, because they can be chained together. So when promise 1 completes, promise 2 kicks off. And when promise 2 completes, we're going to do yet more work in an asynchronous fashion. And when promise 3 completes, we'll maybe write a record to the database. That's sort of the high-level overview. Promises originated in JavaScript. Has anybody ever used JavaScript promises? There's 14 million implementations. You've probably come across one or more of them. This is a fairly generic one. Here we've got a method called HTTP GET. That method is defined elsewhere, but it does some work asynchronously, and it returns a promise. When that promise is completed, we then run the then method. That's why they call it that. When this is done, then run this bit of code. In this case, an anonymous function. That anonymous function is going to log something to the console, and it's going to return the results of a method that it returns a promise. So this HTTP GET method that we looked at, it's going to return a promise. When that's done, it's going to do some console logging, and then it's going to re-enqueue another promise. Does that make sense? Promises can return promises, which allow you to chain them together 1, 2, 3, 4, 5, ad infinitum. When we're all done with our workflow, our total asynchronous workflow, we're going to log to the console the results of our code. So to break that down again, we have one bit of asynchronous code. When that's done, we're going to run this bit of synchronous code, which in return calls a asynchronous method, which when it's finished calls this final method. The basics of promise in a nutshell. Actually, it's like 8 lines of code. You have the ability to chain them together. You have the ability to handle rejections, although in this case I didn't show that. And we have the ability to attach work when the promise is resolved. So, how did this come up? I work with an organization called Pets for Patriots. I'm not trying to stump for them, but they're just a group I work with. And they had a very complex manual workflow, and it works like this. As a nonprofit, they have a certain select group of people that they can help. That select group of people that they can help is largely defined by geographic areas and who's living near their partners, veterinary offices and shelters. The Pets for Patriots organization helps veterans returning from war adopt shelter animals, and so they have to live within so many miles of a shelter and so many miles of a veterinary office to make sure that the animal receives proper care. So part of what we had to do was to geolocate the contact's address. So when a contact says, hey, can you help me out, we say, where do you live? And in this case, we're going to say they live at 123 Sesame Street. And so we take 123 Sesame Street and we geolocate that. And then we turn around and we say, okay, who are all of our veterinary and shelter partners that are within 50 miles of where this contract lives? Pretty simple, right? That's a SOCL query, nothing special about the radial distance search. We then have to turn around and pass those addresses into the Google Driving Distance Matrix API. Now that's, again, another asynchronous call, kind of like geolocating the contact's original address. And when we get the results of that asynchronous callback, we can turn around and correlate the driving distance results from Google back into specific partners. So we know that this shelter is 11 miles from this contact, and this veterinary partner is 15 miles from this contact, et cetera. And finally, if we meet certain conditions, if there's a veterinary office and a shelter within the max mileage range, max driving mileage, we can turn around and we can submit the case for approval and automatically approve it because we know we can help them. Now, if you can imagine doing this for 45 applicants a day, that's quite a lot of click here, put in the information, copy and paste it back and forth, quite a bit of work. But we can automate this entire thing using promises by taking and breaking it down into different steps, each of which returns the next step in the process. So how do we do this in Apex? I showed you the actual how to do it in JavaScript. So we're going to talk about how to do this in Apex. There's a thing called the Queueable Apex interface. It's probably the best part of Apex that you've never heard of. I love this. It's relatively new. I think it's been out 4 releases, and it gives you an interface for the developer to implement to define a promise. And we'll get to how that works here in just a second. There's only one method required in the interface, the execute method. It always accepts a queuable context input. That is dependency injected by the platform, so you don't even have to worry about it. You just put that queuable context that right there, and you're off to the races. And the best part about this over other forms of asynchronous development like add future methods or sort of like batch jobs that are scheduled is that you can construct your classes here with data. So you can put a constructor in your Queueable Apex class and ask it to accept an ID or a string, an S object, whatever you'd like, and do something with that in your execute method. So we'll see what that looks like here too. So this is the bare bones example of what we can do with a promise, how to do it within Queueable Apex. So if we're looking at this, we have a promise example class. It's going to implement the Queueable Apex method, interface, and then we're going to have one method, the public execute. And in this case, all we're going to do is create an account. This doesn't really do us much. We don't even have to do this asynchronously, but for example's sake, we're just going to insert an account. Now, if you look down here at the bottom in the little gray box, there's there's the code you need to enqueue this job. So with Queueable Apex, with promises, you're going to enqueue them. And what happens is you say system enqueue job, you give it a new class, a new instance of your class, and you're off. You'll get back an ID. That's the queuable context ID. You can use it to track the progress of the job, etc. So let's do something a little bit more interesting with this. We're going to chain these another promise together. In this situation, we're going to look and see whether or not our account is null. If our account ID is null, then something's gone wrong, and we want to re-enqueue the same promise. So we're going to try again. And this is one of the powerful features of the promise concept, is that if something goes wrong in a step, you can always re-enqueue that same step. You can try again. And if it does work, if we do get a an account ID, we're going to call second promise. We're going to enqueue second promise. And this is how we do the chaining. Does that make sense to everybody? I'm gonna look for nods, shows of hand. Okay, some of you are nodding, but I think you're asleep. It is afternoon. Okay. So to do this, to make this work particularly well, there are some tips and tricks I want to walk you through that make this a little bit smoother. If you end up doing a completely complex, or you have more than 4 or 5 steps in your workflow, it helps to have a flow control or a process control object, and call it whatever you'd like. The idea here is that you're going to have an S object with an auto increment name, a definition of where you are in the workflow, or it may be a definition of which workflow you're executing, and then you're going to have relationships to other associated objects. So if you imagine we're dealing with accounts in that previous example, we can turn around and have a link to the account, a lookup relationship to the account in our process control object, so that when we query for it, we have that information available to us inside of our at context, or at Queueable context. I also like to turn around and when I chain my promises together, I put a constructor in that accepts the ID of my flow control object. And this allows me to, in every step, look up that record, see where I am, and I can do things like put in a retry count. So I don't want to retry more than 5 times. Every time I enter this constructor, I'm going to increment that, and I'll save it before I hit the execute, at the end of the execute, so that I know where I am. Handy to do that. You can also attach logs to it. So like if you want to do database.batchable when you're doing batch jobs, or stateful, you can start logging increments of things. You can keep adding 2 logs here as well. This is an example promise using the flow control. This is the constructor for it. And in this case, all I'm doing is the first thing I'm doing is I'm querying for my flow control object. This gives me all sorts of bits of information, and you see here that I'm looking for a process name that identifies the process, and I'm looking for the process control ID that was passed in. This allows me to use the same object for multiple promise chains. Does that make sense? Okay. In this case, one of the things that's really important about the flow control object is if you can't get a hold of that record, you should stop the process. Otherwise, you can end up in situations where it continued on and you queued it up again, which can be dangerous for, tax calculations. One of the other things that is a good tip to know with doing Queueable Apex on the platform is that you have to worry about DML context. So when you switch from, while you can queue multiple jobs together, you can chain them together, just because one of them finished doesn't necessarily mean that your DML context has been reset. And as a result, if you make 2 promises, one after another, that both make a call out, the second one will fail with this lovely, you have uncommitted work pending. Has anybody caught that one before? Uncommitted work, it's my favorite Apex warning. Actually, it's my second favorite. They got rid of my favorite. To get around this, you can work with other features of the Queueable Apex interface. The biggest one being that the Queueable Apex interface can be enqueued from any Apex context, including at future context. So you can turn around and you can chain your promises together, and if they need to make callouts back to back, you enqueue the second one through an at_promise method, and I'll show you what that looks like right here. So I have a void method that's going to take in a string that'll tell me which one I'm trying to enqueue. And all it's doing, since this is at future, when I kick this off from my execute method of the first promise, sometime in the future this one will enqueue my second promise, and I'll have my continuity of chaining even though I've broken the DML context so I don't get the extra error. Does that make sense? This one is a little frustrating to work out, but you can also do something similar to this, depending on how you like to organize your code. You can also put an at_future method in your Queueable context class. It says enqueue in future. Same idea, but you're, single responsibilitying it. Questions on that? Okay. So I thought we'd look through some examples, specifically the examples that I worked up for the Pets for Patriots organization. I'm going to show you how we end up starting with a promise by creating that flow control object. That's our first asynchronous step, all the way through getting the results back from the driving distance matrix. So let me switch over to my code. Everyone able to read that okay? I got a yep and a no. A little bit bigger, okay. Let me do that real quick here. How's that? Okay. So here, you'll notice that I've got a method. I like to, a class. I like to prefix my Queueable Apex classes with QA, just so I can easily find them. Puts them all in the same place. And I'm going to implement the Queueable interface, and I'm also going to implement the database allows callouts. That's because one of these steps requires a callout. I've got some basic, constants set up in here, but the first thing I do is I have this create flow control. And this is my constructor for the initial promise, the one that's going to kick off everything. Now this initial promise is shared against many different workflows because all I'm doing here is creating a flow control object. I want to have that continuity through the entire process. Every process uses them. This is where I'm going to create it. You'll see that I'm just basically creating a fairly basic flow control object, and then I'm associating different processes with it based on what I've called in. Because this is the Queueable interface, we have the execute method that we have to implement. And the first thing I'm doing is inserting my flow control object. And if my flow control object can't be inserted, I'm going to stop the entire thing, stop the process. However, on the other hand, if I was able to implement that, if I was able to insert it, then I'm going to turn around and I'm going to call my next step. And I'm going to do that with the chaining workaround method I showed you earlier, where I'm going to chain it through an @future method. So this particular method in the QA utilities class is an @future method, and all I'm going to do is pass in a string, an ID, and in this case I don't have any extra data, so I'm passing in null. Sometimes I need to pass data between promises, and I'll use a serialized JSON object as a string to pass through the @future method. And that's all I've really got to do here. I've got to create the flow control object, make sure it's inserted, and then enqueue the second step in the process. If for some reason I can't do that, then if I can't enqueue it, then I'll get a warning, an exception here. Why would I get an exception when I try to enqueue an object, enqueue a process here? There are limits as to the number of things you can have in queue at any given time. In a normal org, it's about 50. In a development org, it's 5. That can cause some testing challenges if you have multiple processes that are going to be tested in a dev environment, for instance. But I'm going to set this up so that I can catch the exception, and I'll throw that if I need to. When I get to the point where I'm going to geolocate the record, this one, as I talked about in the slide before, I'm going to try and check to see if my process ID is null, and if it's not, then I'm going to pull that record out and update where I'm at in the process. So here's where I grab my record. Again, if I can't grab that record, I'm going to just stop the process altogether. Once I do have that record, I'm going to call into an API to geolocate it. This will give me the lat long that I need, and it'll write it to fields on the record. And again, that's external code. I didn't write that, but it is asynchronous, because it's going to have to make a call out. So I'm doing this through the promise so that whenever it's done creating that geolocation record, I can turn around and then call for a radial search. Otherwise, I'm going to retry again. In this case, I'm going to attempt to make this geocode. This is my geocode step, so if I can't geocode the address for some reason, for instance, I ran into this early on, our development org did not have the Google API license key attached to it. And so I could do 100 a day. And as soon as I hit 101, it would fail. So I want to hit 101, I want it to retry automatically up to 5 times. So this will enqueue the same promise, the geolocate step, if I fail for whatever reason. On the other hand, as soon as I have that information, I can start doing the geolocation, the radial search information. And again, I've got my step in here to grab my flow control object. And I'm going to do I'm going to look up an associated case, an associated account here. Why do I need to do that? But I need the address of that account, right? But I can do SOCL, I can do SOCL, I can do other normal Apex things here in my my Queueable Apex method so that I can actually do meaningful work rather than just passing around data. Queueable Apex allows you to do just about anything you want within an asynchronous context and chain it together. That's why it's so powerful. My execute method is basically going to execute some methods in a library I created. The implementation of that isn't terribly important, but what happens is as I go through and I get my shelter destinations and my veterinary destinations, I can start taking that data and putting it in a format that the driving distance API would accept. And you would think that the geolocation API from Google and the driving distance matrix API from Google would accept the same addresses, but creatively they don't. They like to make it a little interesting and fun. So, wrapping those together and passing that data back and forth is where we come into an interesting bit of workaround where we can actually take and enqueue with the chaining a driving distance search, pass in that flow control ID, but I'm also going to serialize an internal object, an internal class object I created that is my results of the driving distance, my results of the radial search. So I can pass those radial search results into the driving distance matrix API. Does that make sense? And finally, this is where the fun really happens. This is the biggest, in this example set, process. The executable method here is going to be making several callouts to the driving distance API search based on certain criteria. So for instance, I have to make a veterinary callout versus a shelter callout because they have different result set information. So that all happens in this step. And I turn around and at the very bottom here, let me scroll down. If I have both a shelter and a veterinary office within the driving distance limits, I can turn around and submit the case for approval and then automatically approve the case. Taking the steps from the process from doing one contact's pre-qualification from about 20 minutes, copying, pasting everything all around, to about 20 seconds, which has really helped them be able to get through their backlog. Does everyone see how you can chain these steps together and really automate a lot of stuff that takes up a lot of time? Okay. The only other piece of code here I have that I want to show you is the utilities class I had, and this is a bigger breakdown of the @future wraparound or workaround. I've started putting my @future methods individually into my queueable classes so that I can do any one of them without having to add it to this class, but this works as well, easily as well. I'm going to switch back to the slides here, and then we get to start asking some interesting questions. So who has questions? And let me remind you, I like to do interactive participation. If you don't ask questions, I'll ask you questions. We got one right here. Can I get you to use the microphone?
Hi, thanks for the question. Or thanks for the session. I have a question. Can you enqueue a job after a fail, for example, happens? Can you enqueue it to kick off in period of time, like in an hour or something?
So I don't have an example for that, but you can, and what you need to do is write it to a record and have a batch job or a scheduled job that goes off every so often, pick up those records and re-enqueue them.
Okay.
Does that make sense?
Yeah.
And so what I like to do is I like to write to an S object that is my enqueue control, and I'll have it have a delay of X many minutes. And so what I'll do when I write that record, I'll say, now plus 2 hours. And when 2 hours are up, as that batch or scheduled job kicks off, if any time is in the past, it'll pick it back up again. That's a really handy tool. What I typically end up doing just that for is I will retry once. So if I have a failure in a step, I'll retry once, and then if that fails a second time, I'll retry in an hour, and if a third one goes, I'll retry in 12 hours, and the fourth one goes, I'll start emailing people, and there's another 12 hours wait there, and finally after the fifth one, I'm going to stop, and I'm going to email everybody a lot of like, hey, this didn't work. Typically, I'll get the first information warning that I've got something that failed, but then by the time 12 hours has gone by, my information provider is working again, or somebody has fixed their code they broke.
Thanks.
Yeah, that was a great question.
Thank you. I got a question about the chaining feature of the queue, because I practice it. There's a kind of online doc regarding with the chain feature. So if the first job change, right, if I change myself again, then it's gonna have 1 second wait, right? Then another time change myself another again, so 2 seconds and 4 seconds. There's some doc online, but when I practice these things, I didn't see any of this delay. So just wonder, so if there's official kind of things, or it's just maybe already deprecated feature.
Yeah, so the docs don't go into a lot of detail on it, but what happens is when you enqueue a job, it goes into a pool, and as system resources are available, the pool picks up and is processed.
Yeah.
Right? So typically there's a slight delay, 1 second or so, but it's not necessarily guaranteed to be 1 second or 15 seconds. It's just only there could be a delay. Does that make sense?
Yeah, but if I keep on chaining the same job again, so that's according to the doc. Is kind of I read online. It says if that's the behavior, the first job change, right, is get 1 second delay. Then the second time 2 seconds. Then third time is 4 seconds until the maximum is 64 seconds. But I didn't see this behavior according to my practice, so I'm not sure if this feature doesn't exist anymore.
I can't speak to whether or not it exists anymore. I've seen it in practice. Typically, when you get into the double digits of re-enqueuing it.
Yeah.
But I don't even remember what my threshold that I discovered was. But we can talk more afterwards. That's a great question.
Okay.
See if I can't get you a firm answer from somebody.
Thank you.
These are great questions. Thank you very much.
Do you have any additional resources or blogs or anything for like that flow controller? More sample code is what I'm looking for.
It's funny you should ask that. I'm gonna tell you where it is, but I need you to know that I'm not making a shameless plug. Okay, I wrote a whole bunch of stuff about this, but I did it in the context of writing a book. That book has been published. Because it's been published, I can't put it on my blog, copyright reasons. So I'd love to talk to you about it more. If you don't want to talk to me, my book is available. There's a whole chapter on this. That's a great question, though. And again, I'm not trying to make a shameless plug. The book is called Mastering Application Design with Force.com, and you can actually go look at it over there in the little like T-shirt and book shop on the second floor here. You can actually go look at the book. Oh, the name of the book, Mastering Application Design with Force.com. It's got a pretty little island on the front.
Very nice. 2 questions. First, what is your favorite Apex error?
Too many script statements. They got rid of that. Actually, I'm a home brewer. I named a beer after too many script statements. That's my favorite one.
Very nice. Second, I'm kind of new to the whole process, and can you put these inside of a trigger and kind of do the process where it will call and keep going down the line like you were showing from inside of a trigger?
So, yes and no, you shouldn't.
I know you shouldn't, but do they let you?
So, as far as I know, and I haven't tried this, I think you can, but you really should not. Especially update triggers, because if something happens and that update trigger fires again, you've already fired off something asynchronously, you have no control out of the box. You could probably engineer something to check to see if something's already enqueued, but you should not do that.
Okay.
Please don't do that.
Thank you.
Hi. Also new to this, I was just wondering, in terms of transactions, what do the queue jobs count as? Meaning, is it one transaction per job, or is it one transaction per queue?
It is one transaction per execute method. How's that to parse it as finely as possible?
Sure. So kind of per job, you'd say.
Yes, well, it's not per job, because if you re-enqueue that same job, it's a second execute method, right?
Understood.
So it's per execute method.
Understood. And kind of related to this, in terms of DML operations and callouts, are there any limitations as to the order in which you can make them and the number of them within a scheduled job, or, sorry, within a queued job or multiple queued jobs within the same queue?
So within the same queued job, you still have the same, you can make multiple callouts, but you can't do DML ahead of any of them or in between any of them.
Even across queued jobs?
No, that's where the chaining comes in. So if you go to a second execute implementation, to a second promise for a callout, that's allowed, so long as you've broken the DML context by chaining it through an @future.
So you could do DML, callout, DML, as long
Callout,
as it
exactly.
were across.
Exactly.
Great, thanks a lot.
Through that chaining workaround that I talked about.
Right. Thanks.
And that's where you saw the example where I was actually passing in the JSON
Yeah.
to the promise. That's where I'm taking that data that I need to pass across the chain. So if I have a callout 1 that gets time and temperature, for instance, and I need to pass that time and temperature, or actually better yet, an authentication token. I go authenticate to an API. I need that for a second API call. I can then pass that to a second queuable context as data into the constructor and have it available in my execute method. Does that make sense?
Yeah, it makes sense.
Yeah.
Thanks.
So actually, your answer to that question is exactly my question. I'm not really understanding the purpose of why you use the @future, because each queuable is going to be a separate transaction. So even if you did DML in a previous queuable, if you chain a new one, doing a callout should be fine. You're under the context of a new transaction, correct?
I understand, and I agree with you from a conceptual basis. From boots on the ground, however, you will receive, you have uncommitted work pending errors unless you go through an @future step. I don't know if that's an undocumented feature or what.
So I know you're not supposed to, call this on a list from a trigger, but if you have some other list, is it okay to implement a custom slice method and pass in the list and process it 1 by 1 or 5 by 5 or whatever you want? Or is that still not recommended?
I don't see a problem with that, except for the governor limits regarding the number of jobs in queued. So I could see yourself getting into a lot of trouble really quickly, especially if you have multiple jobs that would be slicing.
Right, but it should be rate limited, which should hopefully protect you, right?
Well, the problem is the rate limiting is on the in queue of the job.
Have to do some more testing, I guess.
So the thing is, if you've got 49 in queued and you queue up the 50th slice, and then you have a 51st slice, you have to wait. And you may run into a situation where there are not enough resources to burn through that fast enough for you to queue the 51st.
Right, so I guess medium-sized jobs fine, but maybe anything bigger, look at a batchable.
Yeah, I think I would still probably lean towards batchable on that kind of thing. But there's no reason your batchable can't turn around and invoke something or enqueue something that is a queuable apex. These have been great questions. Bring them on. Bring them on.
I want more clarification on the limits. I know the initial process can queue many, and then if you chain, you can only queue one. Is there a limit in the enterprise license of how many total queue jobs you can have? And do you get a failure on the queue method if you exceed that?
So in practice, you can enqueue from, you can chain together
Right.
any number of queuable
Right,
apex.
I get that, right. What I wonder about is suppose you had 1,000 users and they all pressed the magic button that all caused Apex to enqueue. So instantly 1,000 separate, completely separate processes, all enqueued, different queuables. Would
Yeah.
that hit an Apex limit?
Yeah, you're going to hit an apex limit on the total number of jobs enqueued.
And that's still 50, just like batchable, or?
Don't quote me on 50. I think that's the enterprise level. I don't have the documentation open right
That's
now.
a
We
really,
can look
that's a,
right
that's a
after.
make or break question.
I
because-
believe it's 50.
Because
That's
the
my.
promise breaks if that enqueue method fails. Then somebody gets an email and they got to pick up the pieces by hand.
Right, and so I always recommend that promises be used for non-user triggered events.
All right.
Okay, so there's some exceptions to that. You know, the example I gave, that's a user triggered event. The save or update of, it's actually the save of a new contact, the insert of a contact triggers that off. In our situation, we were dealing with 45 of those a day, and they're spaced out throughout the day. And so we're generally pretty good with a 5-step process and a total of 50. you can really run into issues in a dev org where you have 5 that you can enqueue. Yeah, I'd have to look it up to give you an exact answer.
Where would I look it up?
So if you search, so I just noticed this today.
Because I tried to look it up, and I spent an hour looking for that answer
Yeah.
last week. I couldn't find it.
So quick answer to that is if you go to Google and you type in Salesforce Apex limits, they now have their own little like thing that pops up, a little grid that tells you this limit, so on and so forth. That's brand new. I hadn't seen that till before today. And secondly, if you actually search for Apex Queueable interface, it'll pull up, and they have a blurb at the bottom with those. I'll meet with you right after this session, and I'll show you where I'm getting my data, and we'll nail that question down exactly. Other questions?
Yeah, I was just wondering, have you ever thought about using an interface instead of storing the step name, and then dynamically instantiating that interface, and so that you just have one queuable implementation that will run any number of classes that all implement the same interface?
Here comes my forward-looking statement. I'm working on it. I don't find myself with a lot of spare time, unfortunately. If you want to, let's swap business cards, and maybe we can work on it together and get it out faster.
Yeah, that'd be great.
Yes. Other questions? Oh, got another one. Yay.
Can you do parallel processing with promises? So can you kick off 2 queued jobs, and then only when the result of both of them come in do you do a third thing?
Yes, but I did not show how. You do that with your flow control object. You can have it say these steps have been completed, and when you are, when this is true for both of these steps being completed, then kick off this queue, this queueable Apex. That's a great question. I don't know why that slide didn't make it into the deck. I'm kind of kicking myself now. Does everyone understand this question? One of the features of promises on JavaScript is the ability to say, here's 5 promises. When all of these are done, then do something. And it doesn't matter which one of those 5 completes first or last. When all 5 of those are done, then do something. And you can do the same thing in Apex using that flow control object. Great questions. More questions? Yes. I love questions.
Not really a question, but I found a hacky way around the uncommitted work pending exception.
Do tell.
So I set up essentially a dummy HTTP request class that mimics the standard one, and then I serialize that, pass it on to a Visualforce page as a parameter. Then that Visualforce page actually performs the callout, and then has again a dummy response that then gets serialized and rendered on the page. And I use the page reference get content method to grab that JSON and rebuild the request.
One of the things I love about the Apex platform is you're either going to be a really good programmer who's very creative, or you're going to be frustrated a lot of the time. And that just sort of proves my point there. Yeah. I think that would be an especially useful workaround for promises that were UI-based. Mm-hmm. So if you've got a Visualforce button that's going to kick off some asynchronous work, I'd probably look at doing it that way. Yep. With the recent change to make get content a API call that is considered external, however, that may not always work.
Okay.
Because essentially you're going to be making a call out to get that get content.
Mm-hmm. Yeah, I mean, the reason I kind of played around with this was because I had an Apex REST web service, and then that had like create a record. I had to get the ID and then like pass the ID to another external system. So I had to do a DML and then I call out with the same context. Mm-hmm. But yeah, it's available on GitHub. It's called Apex Callout Delegator.
Okay, Apex Callout Delegator. Other questions? I'll even take comments and signed remarks. All right. Well, thank you very much for coming. I appreciate it. Y'all have been awesome.